Welcome to the Embedded Frontier podcast, where we explore modern embedded systems development techniques so that you and your team can develop faster, smarter firmware. I'm your host, Jacob Beningo, founder of Beningo Embedded Group, the Embedded Software Academy, and co-founder of the Embedded Online Conference. All right, well, welcome back to the Embedded Frontier podcast. In today's episode, we are going to be continuing our modernization talk. And today we're talking about DevOps. So with me here, I have Darwin from GitLab. So Darwin, how's everything going?
Going well, thank you. How about yourself?
Doing wonderful. So Darwin is a fantastic resource and expert on DevOps, CI/CD, and he's been doing a lot of really interesting work related to embedded systems and how we use DevOps. So I'm really excited to have you here, Darwin. I know every time we have a discussion, my mind goes, oh my gosh, there's so much more to this than I ever thought of. And then I see what you're doing. I'm like, oh man, this is really cool stuff. So I hope, I'm really excited to talk with you today and have you share some of the things you've been working on and some of your insights as well about what's happening in the embedded systems industry around DevOps. So with that in mind, do you mind giving the audience a little bit of a background and introduction about yourself?
Sure. I work out of GitLab's field CTO office. And one of my primary roles over the last year has been to look at how we apply to the embedded subsystems capabilities and what developers need out of DevOps, what they're looking at. We have been digging in deep to understand what the platform can do today. GitLab is a lot like a Lego box. So a lot of times you can do a lot more with it than you know until you really get into it. And that has been the case with embedded systems. We've been showing up at conferences, writing materials, getting lots of working examples in a workshop ready to go so that we can enable the ecosystem in what we can do today. And then throughout all of that, also just connecting with customers and finding out what are some of their primary challenges, what are some of the compliance things that are facing them that have been new over the last couple of years, as well as some legacy engineering concerns with the engineering V and of course our wonderful friend functional safety. So a lot of different factors for us to factor into our thinking in terms of coming really from a more of a cloud, mobile SaaS developer paradigm.
Excellent. So you kind of mentioned legacy code and kind of coming from a cloud background in general. How do you feel about the adoption of DevOps within the embedded systems industry? Is it I don't want to lead you in too much of a direction. What was your first impression of it so far with your experience?
So I wanted to make sure that when I started thinking about this, that I was very measured because it made sense to me that there had to be some fundamental business level differentiators that were holding back DevOps adoption, and not to assume it's just people stuck in their ways or their habits, although there's always that, right, in any organization that has humans in it. So, but I think the fundamental thing was to step back and understand in what ways are the whole cloth DevOps ideas of pure software products applicable and not applicable to the business needs of embedded. And I think that was one of the interesting kind of ways I've been talking about it, is that if you look at the lean startup and a lot of the books that talk about even business level innovation with software or what we call digital, they pretty much assume that software is the whole product. So when you ship the software, you've shipped the product. And so I tried to spend some time on this differentiation that in embedded, that's the exact opposite is the case. Shipping software does not mean shipping product. So yeah, it's been very interesting to dig into that area and find that also I really found that embedded's not just one thing. So I really started separating it into three concerns. One would be digital disruptors and smart everything. And in this realm, frequent updates to add functionality are considered good. Not as frequent as we talk about in DevOps to the cloud, 10 times a day to production. An end user doesn't want to see that happening to a device, or we don't want to see that happening to a hydro dam, right? Yeah. And then as we move right, we get into smart machines, or boring or stable machines. So factory floors or gold mining trucks where they should just operate solidly like a machine. And if they're down, they can cost thousands or millions a day. And then finally, functional safety machines where if software fails, we might have human harm or even death. And so these three camps, in my opinion, they really have to approach things in different ways. And it's important that when you go to talk about how DevOps and Agile might apply, that you have the customer's use case in mind. I had one customer recently, we talked about componentizing their embedded software. We got to a model that would seem like a ridiculous level of granularity of repositories, but they were creating a solution that's ASIL-D. So keeping all software to be super deterministic, like it's a little state machine, and make it so there's very low change. That's a really high priority when you're having to do ASIL-D, right? So it made sense in the end, even though it looks super complicated compared to what we might think about in terms of web software or SaaS software.
Perfect. Excellent. Now, as I was kind of preparing to talk with you, you've got a lot of great resources and talks and blogs and stuff like that that you've put together. So I'm going to try to put some of those, in the resources here for people to check out because there's a lot of great stuff in there. But as I was looking at everything on the GitLab website, I noticed that, just as an example, it kind of mentioned that in 2025 here, a typical automobile actually has 650 million lines of code inside the vehicle. And that's up from 200 million lines of code just 5 years ago. What does this rapid growth in code complexity mean for embedded developers, and how does a DevSecOps platform help manage all of that for them?
Yeah, so I think one of the important parts to realize when we use those lines of codes is we sometimes think of them like I heard it compared to an average vehicle compared to Facebook. With
Yeah.
Facebook has like 90 million lines or something like that. I don't know what it's up to today. But that 90 million lines is one code base. And one of the things we do have in anything that's physically engineered and composited together, complex like a car, is systems engineering requires boundaries which have very strong interfaces so that teams can build inside of those boundaries and not have to, build each part sequentially and take 10 years to build out a car. And so I think one part of that aspect's already been dealt with well with systems engineering is that within these subsystem boundaries, that is really the code base of concern. So when we bring this kind of complexity into DevOps, we want to make sure that we are doing all the builds in a way that allows us to do the automated testing that DevOps is famous for at different levels. One thing I've noticed is frequently when people talk DevOps, they always talk, or they frequently are referring to the continuous deployment to production of chunk-based development. And this is only one way that you can put your DevOps together. So if you read the continuous delivery book by Jez Humble, he talks about a succession of environments where you get more and more production-like. And what that allows you to do is to have certain things operate in sort of a stubbed out mode. And this is quite common embedded with testing parts of code that aren't even a fully assembled firmware yet, then getting it to the firmware level, testing in software. So I think the important thing to realize is that DevOps has a lot of ways of compositing all of these subsystems together. There's capabilities to create different repositories for source or different repositories for packaged or partial artifacts that you want to test. So you have one potentially monorepo, but it's packaging into other projects in order to create a granularity at the packaged level. So there's a lot of ways to combine Git itself as well as the projects inside of something like GitLab and the permissions that are on them, tokens. There's just a lot of levers you have to accommodate that complexity and make sure that you get the developers who are working on a subsystem need to be really in a tight integration loop, right? They don't want to be fully integrating with everything every time or running every possible test. So I think it's just really important to have a succession of environments that allow you to get more and more serious about the testing as you go along, so you don't end up with 6-hour pipelines to add a few lines of code to a small feature.
Absolutely. So another thing that I've seen, working with some embedded folks, we always hear about the works on my machine type of syndrome, right? Where
Yes.
inconsistent build environments from one team member to the next. what about when you think about that, you sometimes end up with maybe knowledge silos and just inconsistent builds. How can containerized builds and centralized build environments help eliminate some of these problems and improve auditability even of the software itself and maybe even testability?
Yeah, that's a great question. I think one of the things that is important to realize is that um, embedded developers have necessarily been operating at the desk because they have to be attached to hardware in order to have a tight loop and have a more realistic testing environment. Over the last about 5 years, ARM's the exception, they started in 2014, but a lot of the vendors are now virtualizing their embedded environments and test environments in order that developers can move faster. And that's an important part. But one of the things I'm concerned about is that when developers start to invest in CI/CD, they view it as just a way of doing faster builds and don't understand these differentiators that you're talking about with development environment assurance, runtime assurance. Also, when we go beyond the desktop, so as you alluded to with containers, you can do that locally. You can get an assured build environment and run that container maybe as a sidecar to build your stuff, and you can have different versions of runtimes. But as soon as we move into a shared development environment, now we have a whole other different level of capabilities. I have been surprised in interacting with the embedded community that they don't know about software supply chain security in the form of SALSA attestation. And what this does is it allows you to say, this particular artifact was generated on this exact runner at this date and time, this runner version, and it uploaded this artifact. The artifact could be a text file, or it could be a firmware file, or an intermediary binary artifact, and it will checksum it. So right from the point of whatever machine you were on, you get all these interesting details as well as a checksum. So you know, as long as there was no bad actors on that particular unit, that you have a validated upload. And then once you get it into the pipeline, we have a lot of ways of being able to collect pipeline evidence into packages. I have a GitLab component that will collect all artifacts, all logs, the exact CI code that was used to do the build, all into a archive that is then signed and re-archived with the signature so that you can store it somewhere for long-term keeping. And so all of that information will give you exact version numbers for containers, exact information about what code ran so that in 5 years you can pick up and reproduce the build. And so all of this flows not only into the new compliance regulations that we have had come out in the last couple of years, but your legacy functional safety compliance that you're on the hook for, as well as traceability, R156 for being able to trace software from a identifier that is visible in the end device all the way back to what source code built it, and then therefore what environment built it in case you need to fix it with minimal variation in the pipeline. So yeah, getting onto those shared resources is as important as getting into containers in order to have a validated build environment that's reproducible, that's also corporate knowledge instead of it being kind of floating around in the heads of 20 engineers. I've been worked at cloud organizations where it would take a week or two for a developer from the time they joined the organization to get the first build because they had
Oh,
to go
wow.
around to all the experienced developers saying, now this is broken. Now I run that command and I get this error. And I had to perfect that build so it could be virtualized. And that's an example of, not having the corporate knowledge to actually fully, get your software out to production. So once we put this into shared systems, it can make sure that we have all the knowledge we need. It's explicated into actual code, and then we can start getting that traceability as well.
Fantastic. So I think that's kind of interesting there. You also mentioned a point about compliance within that within the kind of the framework here. What approaches a lot of times a lot of developers today, especially embedded developers, are doing manual compliance. We don't have a lot of teams aren't fully using automated compliance, which a lot of times
Right.
causes kind of late stage issues, documentation burdens, bottlenecks, etc. How does compliance as code and continuous verification help teams meet standards like ISO 26262, MISRA C++, without slowing down development?
Yeah, so in as much as those compliance standards depend on software generation capabilities, we can apply automation to them. It should be noted that testing, say, a certain device in a temperature of 130 degrees is something we can't fully automate, right? So you have to have the proper physical setup. But one of the interesting things in GitLab is we still have the ability to do checklists. And these checklists, when you check the checkbox, it records it in an immutable log. So there is the possibility of even bringing some of the manual compliance into a merge request or into an issue and start to track some of those checklists right inside the same system that is responsible for doing all the automated software capabilities. But definitely driving towards fully automated QA. One thing we saw in cloud was that people, were really excited about the Jez Humble book. They started implementing, but because at the time there wasn't a lot of coding QAers, QA engineers, that was kind of left. And then eventually, you'd have an executive say, "What's going on? We've invested all this into DevOps, and we're only 10% faster." And a lot of times it came down to manual QA. Setting up those manual QA environments was not automated. Getting them set up and then having the QA folks, cycle in behind that. It would also cause the iterations to become bigger because you don't want an entire QA team. Humans can't sit there and do something 6 or 7 times a day that's a really elaborate checklist, right? They'll lose their ability to focus, and so it actually slows everything down. And so that's one important part, is making sure as much QA as can be automated is automated, so that your limiter becomes other constraints other than a manual QA process. So that's a really big part. And then just collecting evidence, also understanding what evidence you already have. We have one partner who has a solution that uses AI to identify, hey, you have this compliance control you're trying to meet, and over here there's this log file that would appear to meet that without you doing anything new, And so that's another aspect, is really understanding what's already in the build capabilities, and then also enhancing them to explicate or to actually put information out that is then able to be scooped up by compliance processes. For instance, build logs frequently are very minimal. They don't do a lot of success logging. And then when they do failure logging, it's frequently inscrutable. And so one of the things here is the ability to, start doing more success logging. And in this case, for compliance is also super helpful. But yeah, once something gets into that pipeline and it's in an automated fashion, there's almost no limit on what we can capture and start giving evidence for.
Fantastic. What do you think about AI as well, right? We can't get away from AI today, right? Every time you open up the news, it's either a AI bubble or,
Yeah.
Nvidia, beating earnings or whatever it is, right? In ways that, we never thought they could, right?
Yeah.
How do you see AI playing a role within DevOps? Is there a place for it to have a role, or should AI stay out of DevOps? What's kind of your thinking about that?
Yeah, I'm kind of proud of what we ended up with at GitLab, because we were a DevOps platform before AI came along. So when AI came along, we didn't just ask, how do we generate the best, fastest code on the planet, or as much code as possible? We asked about, how do we apply AI to the entire platform? So this gives two obvious and one non-obvious benefits. One is the ability to actually have put AI into your actual customer product solutions. Another one is to use AI for coding, code generation, and creativity around that line. But a third one, because we built it throughout the platform, is to onboard to DevOps. So I frequently use the analogy that if we have a set of engineers who aren't making embedded, they're making toasters, not smart toasters, just regular toasters. And there's a team of 15, they come up with the next game-changing, world hunger-solving toaster. When we go to make that toaster, we don't ask all 15 of those developers to become production plant engineers. So they learn how to build a plant that builds a toaster, or configure a plant that builds a toaster. And so inside of GitLab, we have a lot of ways of encapsulating that, how to build stuff, and then emitting it so that the regular developer doesn't have to really get into the details. For instance, I have a SEM versioning component that completely automates something called Git version, which gives you automatic SEM versions, no need to store stuff, really thorny problem solved very simply. But if an average developer is using that component and they're like, what is this thing doing? I don't get it. Inside of GitLab, they can say, explain this CI log, and they can even explain the code behind the CI log just from that simple prompt. So if you think about cognitive load of your production or your product creating engineers and them being asked to onboard to DevOps, they can feel a lot of angst about the processes involved, about the tooling involved, about being distracted and not having enough time to do the customer facing product details. So by having AI in the platform, I believe that it's going to be really helpful for embedded because embedded developers can stay focused on what they need to, and they can do just enough training just in time for things like security vulnerabilities or other findings. And if they have a build failure, they can find out, is it my code or is it the CI code very quickly and easily? And so I think this is one of the hidden benefits of applying AI at a platform level is that it can really help you onboard to DevOps automation, to security, to continuous compliance, because it's built in there throughout and helping you understand what's going on in this system that I'm not going to become an nth level expert in by default.
Excellent. Very cool. Yeah, it sounds like a lot of really cool stuff going on there with AI for sure. What about other things that you see? Do you have any other things that you're looking forward to that you see coming up in the future for DevOps that you're allowed to share, of course, right?
Yeah. I think really the really big thing is just ensuring that we don't apply software as is the whole product, whole cloth DevOps to everything. I've had situations where a manager of a DevOps team comes to me, or of an embedded team comes to me and says, this is my first embedded team, and I don't understand why this is not happening, that's not happening, no one's interested in that. And frequently it is these valid business differentiators that are the difference. And so I think it's really important not to approach the whole world with the software is the whole product mentality when we're putting the software inside of machines, and some of them do super important jobs in society, and some of them have implications to human safety. So we have to make sure that we get as agile and quick as possible, but don't go faster than necessary or faster than would be safe. So I think it's frequently agile has been called safety, speed with safety. So agility is not really about raw speed. It's actually about maneuverability. So some of that is speed, but the other part of that is the ability to to take everything in the right way and to apply it correctly. So I'm really excited to apply more DevOps and Agile to this world. I also feel that the deployment side, I think a lot of folks are getting this right in that in embedded, we want to think of continuous delivery, which means release ready, release software release. So you have a firmware bundle that's ready to be installed in production and not the continuous deployment to production in the same way. Even when we are responsible for deployment, for instance, with software-defined vehicle, frequently those have to be managed deployments because you can't afford for one endpoint to go unupdated. Where, of course, in the cloud, we just terminate all the containers of the old version and start up the new ones, and we don't have to worry about stragglers or the occasional failure, and you don't have that kind of tolerance in embedded when you're doing over-the-air updates.
Yeah, absolutely. Well, awesome. Thank you very much, Darwin. We really appreciate you sharing your knowledge about what's going on in DevOps today. Any final thoughts, or do you want to share with the audience where they can find you or point them to anything that you think might be of interest?
Sure. We're at GitLab.com. You can find a lot of our embedded content at fastlink.io/GLEC. So that's GitLab at embedded conferences. And so we try to keep that as a resource. And then we also have an embedded DevOps workshop that you can do self-paced, quite extensive, walks you through starting with the working at the desk kind of scenario, and then eventually take small pieces of that off until it's completely automated into GitLab. So those are a couple of resources that can be quite helpful. And then always, understand that at GitLab, we have the embedded competency. We can help your teams understand and adapt to DevOps and to your GitLab usage so you're getting maximum value so your teams can become more innovative in the marketplace with your customer-facing solutions.
Awesome. Perfect. Thank you very much. Really appreciate it, Darwin. Again, it's always a pleasure talking with you, and I'll make sure that those resource links are in the show notes for everyone to check out. I think you'll find that there's some really some great some resources. So, all right, with that in mind, thanks again, everybody, and happy coding.
Thanks, Jacob.
Thank you.